In this video, you will learn about solving radical equations. A radical equation is an equation that has a variable in a radicand or has a variable with a rational exponent. And a square root equation, which we're going to be focusing on, is a radical equation in which the radical has index 2. And below are two examples of radical equations. Now, in order to solve a radical equation, you are going to first isolate the square root. Then you will square both sides of the equation to eliminate the square root, solve for x, and then lastly check for extraneous solutions. In our first example, it says solve each equation. Remember to check for extraneous solutions. Now, since the radical is already by itself, we're going to start by undoing the radical. Now, the opposite of a square root is squaring it. So we're going to take both sides of the equation and raise it to the second. Now, this raising it to the second power undoes the square root. So it becomes n plus 6, and 3 squared is equal to 9. Now, if we want to solve for 6, you'd have to subtract 6 from both sides to get that m equals 3. Now, for each equation, a part of this is checking that your answer works. So in order to check, we would take our original equation and substitute the 3 in for m. So it's the square root of m, which we now know is 3, plus 6 equals 3. Now, if you simplify, 3 plus 6 gives you the square root of 9 equals 3, and the square root of 9 equals 3. So since 3 equals 3, that means that your answer is m equals 3. In our next example, where again, since the square root is already isolated, we're going to start by raising both sides of the equation to the second power. Now, if I raise the left side with the radical to the second power, it undoes the radical, so it becomes 11n plus 3, and 5 squared gives you 25. Now, to solve for n, you're going to solve like any other equation. You would subtract 3 from both sides to get 11n equals 22, and divide both sides by 11 to get n equals 2. Now, to check, we're going to plug it back into the original equation. So our original equation was the square root of 11 times, we solved to get that n equals 2, plus 3 equals 5. Now, if we evaluate, 11 times 2 gives you 22 plus 3 equals 5. 22 plus 3 gives you 25, and the square root of 25 is equal to 5. Since that is true, we know that the solution is n equals 2. In our last example, the radical again, now it's on the other side of the equation, but it's still isolated and by itself. So you're going to start by raising both sides of the equation to the second power. Now, 2 squared would become 4, and b over 6 under the radical is canceled out, so it becomes just b over 6. Now, to solve for b, you are going to use the inverse operation of division. The inverse operation of division is multiplication. So you multiply both sides by 6. So 6 times 4 becomes 24. These 6's cancel out, so it's equal to b. Now, to check, you're going to plug it back into the original equation. So the original equation was 2 equals the square root of b, which we now said is 24, over 6. Now, 2 equals square root of 24 over 6 becomes 4, and square root of 4 is 2. So since 2 equals 2, your final answer is that 24 equals b.